Welcome all. Today we will discuss the unification in first order logic. This is unification as a very important concept in the AI, that is the artificial intelligence, particularly in logical reasoning and inference rules and in systems. This is one of the basic process of making the two logical expressions identical by finding the suitable substitutions, and this concept is widely used for automated the reasoning and then theorem providing and logical programming, etc. So in this slide, we can look the basic conditions and required for the unifications. So the first condition is like the predicate symbol must be the same. So that means what? So we are having the two expressions and then the different predicate name. It will be just the condition cannot be unified. And then the second thing, that is here the number of argument in the both expressions must be identical. So that means the both expressions we are having the different kind of the numbers and then unifications and then fails, etc. So this is one of the second condition. The third one is the unification will fail if there are two similar variable present in the same expressions. So that means what? So we are having the two expressions of names or variable or numbers, etc. It will be present in the same similar into that means the unification also failure. So these are all the basic condition. So the first one is what now? That is a predicate the simple must be the same. So it will be just predicate whatever the symbol it should be there, so that the condition it will be checking. So we are having the different kind of the names and then variable means the condition it will be satisfying. And then the second thing is the number of the argument must be the identical both expressions, like the different kind of the unification and then numbers and then variable means the system it will be okay, otherwise it will be making as a fail. The third one is what now? The different kind of the variable that should be present, but the same expression or same name it should be like that means the unification condition also fail. So this is the basic information for we can before solving the unification process. So this is the important condition. So these things we can able to understand means, so we can easy to solve that. Next, the following examples. So this is the basic example for the thing. So the first statement is so unify the nose and then the bracket of John comma X and nose of John comma Jenny. So here what the thing is happening here, so we are having the same name, but the other position is we are having the different the name and as well as the variable. So what the thing we are going to unify? So the John we cannot able to unify because the same name is happening here. So that so we can just store into the other term is X is given by the Jenny. Okay, so we can make like that as a theta as the like what now the final outcome from the unification process. So this is the one of the particular statement. So we are having the same name, but here we are having the different names and then variable. So these particular variable it will be storing as or given by the Jenny. So this is the first thing, so that the unification it will be valid and then successfully evaluated. The second condition is unify knows John comma X comma knows Y comma Bill. So here we are having the two variable X and Y and then two names John and then Bill. So what the thing is happening here mean, so we can make with the theta equal to the final outcome and then bracket. So X, the first variable is what in the particular context. So X is given by the Bill and then comma the Y is given by the John. So here we are having the different kind of the variable and then different kind of the names. So the unification condition is satisfied. So this is the basic and then simple example for the understanding thing. So now we can move with the little bit of complicated. So here you can look at the first statement, unify knows John comma X and then knows Y comma mother, and then again we can store like the Y as the context here. So whatever the variable it will be happening and then by variable it will be assigned some of the name means directly we can take with the help of Y. Okay, so finally we can extract the outcome is the theta equal to the x is given by the mother it will be stored as a John. But the John means what? The y is given as the John. So y as a variable it will be already stored into the John, so that we can easy to access with the mother of John here. Okay, so this is the little bit of the the some mode complex example. So here we are having the John, here we are having the mother as the one of the different term here. Okay, but here we are having the variable x and then y, but the y is happening the two times, so that we can just store into the y as a one of the naming variable here, and then that particular variable we can access with the other hiding variable over there. So the final outcome, the x is given by the mother, but the y means what? The y of the John. So directly we can just connect with the John of the name here. So this is one of the critical and then critical term over here. The next example is unify knows and then the John comma x comma knows x comma Elizabeth. This is one of the statement. So here what the thing is happening means John also there and then Elizabeth. So we are having the two different names, but there's only one variable, same variable we are having happening. X as the we are having the same variable. Here we cannot able to store the two names, because John has a different name, Elizabeth has a different name, but here the x is the only one variable. So we can possible to store any one of the name only, so that the condition it should be fail. So here same these condition is happening. How we can able to avoid these kind of the statements means we can apply for the standardizing technique. So what is that? We can apply for the standardizing technique. So we can help for the standardizing technique, so we can avoid these kind of the problems. So how we are going to overcome this process means, to avoid this kind of the process, we can able to access the two kind of the variable x and then y, because the name is different name we are having, but we need to just access with the only the variable, only the different variable we can able to access means the condition it will be standardized, it will be what is that condition, and then the good outcome we will get it. So that's why we can do with the standardizing process. So how it will be, how does work for the standardizing process means, the first one knows and then x, already we are having the x as a variable, so that we can store the variable for Elizabeth. This one it will be just implies to the knows y comma Elizabeth. Okay, so here what the thing is happening, the x as the Elizabeth, so same it will be happening, and then accessing for the different name, different variable, so same name is happening here. So this is the condition for using that. So finally what the thing is happening, so this is the one of the possible way. So the exact from the statement, so this is the exact statement, x Elizabeth, the knows y Elizabeth. So these kind of the thing we should avoid, like the standardizing technique. So how we are going to store the variable means, the theta equal to x as given by the Elizabeth comma y is given by the John. So here what the thing is, we can use with the standardizing technique, so we can use with the y as a new variable name for assigning this different kind of the variable here. So this is the process of the critical term. So this is for the thing is, first statement is what now, so we are having the name, different name and then different variable, but that variable it should be just access with the again of the mother of the function over here. So that's why first we can store the variable for the particular name, that particular name we can store into the another name of the name here. This is the first context. So the second context is a critical sum is sum or statement is, we are having the different name but the only same variable. So these process we can able to use with the standardizing technique. So we can change the variable name, because in the context they have given the like the different name. So we can able to use with the different kind of the variable with the help of the standardizing technique, so that we can use here, like the x it will be stored as a Elizabeth, and then y it will be stored as the John. So this is the why we can able to solve with the standardizing technique. In the same thing, we got the different name. That's why we can proceed with the standardizing technique. But the same name is happening means the condition it will be definitely fail. We cannot able to proceed with the standardizing technique. So this is the basic functions of the overview of the first order logic. So thank you.